Digital slump solution have been around for, I think the first attempt that we had at was in the region of 15 to 20 years ago. If you would have asked me 15 years ago, is it worth looking at it? I say with my wet batch background, I would have said probably not. 10 to 5 years ago, now being in the UK and 50% of our plant being dry batch, I said, well, actually, that's not a bad idea. But now that we've implemented that, I can tell you that the feedback that I've got from the operation technical is that they don't want to go back to what we used to have. And this is mainly because this has given us the ability to monitor the concrete from the concrete plant to the job site, which is giving us an extra insight of how the concrete is behaving. So just to set things in perspective, the reference in the ready-mix business is what we call the slump test. So I think most of you are probably familiar with that. It's good to know that this is something that's been invented now over a century ago, and we are still referring to that as the reference for any test that we are doing. So the good thing about that test is that it's very easy to implement. The downside of that kind of test is that it's very prone to human error. I can take 3 guys or girls within the audience. We do a slump test, and it's almost guaranteed that you would get 3 different results. So very prone to human error and very labor intensive as well. The solution that we've implemented with load assurance from Command Alcon is what we call a digital slump solution. So I'm going to talk you through quickly. I've got a prop actually. Jim, can you pass that through? So what you can see on that slide is basically the system by itself. So what Jim is passing through is in fact the probe that is fitting directly onto the drum, connected to a solar panel, and connected to this display via Bluetooth. Then from that external display, we've got a wire connection to the water meter, and the display is itself connected to the central unit that sits in the cab. That central unit communicates via Bluetooth with the truck tablet, which send the data onto the cloud. And after that, we are able to recover and analyze all the data, which are, as you can see in the next slide, I'll talk about that later. We're monitoring the slump. The slump and the technology that we use to monitor the slump is in fact, think of that sensor as a load cells on which we apply pressure. So we will read a value in kilopascal that will be translated into a slump reading. That is valid for any slump families, slump flow, and flow mixes. We can monitor roughly from, at the moment we're getting as low as 80 slump, up to 250 for the screen, and then for the slump flow we've got anything from 550 up to 700, 750. So the calibration is exactly what I was discussing. It's very straightforward. Basically, when we calibrate for the first time, what is important to associate is the material package that we use for the aggregates with the type of drum. So London, for example, we're using only Stetter drum and McPhee drum. We will do one set of calibration for each of those drums for that particular material package. Once this is done, we can propagate that to the whole fleet. And as you can see, I don't know if it's really readable, but I can't magnify because we're recording. On the right-hand side, you can see there is direct correlation between the pressure and the slump. Just a bit of an insight of the stuff that we can measure. So in red, you've got the slump value. The gold is the volume. Then, of course, I've got the water addition here that hasn't been selected. We can monitor the temperature, the water cement ratio, the rotation speed of the drum, and the pressure in the sensor, as well as the speed of the vehicle. So, as you can tell now, from here, when we finish loading the truck, to here when we finished discharging the concrete, we've got complete realization of what is going on, and this has already helped us with a lot of improvement. I mean, from our side, from an operational point of view, we've been able to optimize cycle, optimize mix design by following the slump decrease or increase. We can target the admixture dosage or the utilization of recycled water sometimes being detrimental. On the customer side, some of the pilot customers that we use have managed to reduce their testing frequency to almost none by following the system for a couple of weeks. They realized that the manual test was within 10 mil of the slump with load assurance. So they decided to remove completely the test on site and only test by exception, which means when the slump is outside of the desired target, we can move on. Big benefit for us as well, we are able to monitor the discharge volume here. So we know exactly in case of there is any return concrete, how much concrete is left in the drum. On top of that, as probably most of you know, we've got an app that we use for order taking and delivery monitoring. It's an internal app. We've interfaced the load assurance data with that app, so now the customer is able to monitor directly if the truck is equipped with load assurance. You've got a green tick here on your delivery, and you can see the target versus the real slump, the temperature, and the same here when he's on job site. So I think with this kind of project, the real asset is the data behind this, and this is what I wanted to conclude with. At Heidelberg Materials, what we're trying to do is to create a kind of ecosystem where we're going to pour a lot of data that's going to be made available for the customer. That's part of another presentation for all the digital solution, but you can really envisage that tomorrow from your BIM software, you can interrogate the GI-Tech probe that is into your concrete that will be connected to the load assurance, which has monitored the load from the batching plant to the job site, and then we can even go back to the batch record into the batching plant to get the full traceability of the concrete. And that's it.